Thank you, Tish. Okay, you guys can hear me. All right, as Tish mentioned, we have just some of the leaders in the field up on stage all in one place and talking about interactions, all I think pretty much on the AR side, which I'm more on the VR side, so I'm very much looking forward to their talks and maybe having some insight of mixing both AR and VR together, or maybe not. I'd love to hear their input maybe later in the panel. But what I thought I'd do in order to keep you guys awake is to offer you an incentive. If whoever tweets repeats something that one of our panelists said that's the most insightful, they win a free copy of my book, the VR book, which a large part of that book is dedicated to interaction. So go ahead and tweet, include AWE 2015, and we'll announce the winner after the show here. Okay, with that, we'll go ahead and have Frank. Frank is the chief designer at Atheer Labs and former vice president and chief of design at a little company called Nokia. Perhaps some of you have heard of him. And he's received many awards, and his work's been featured in museums all over the world, amongst many other things. But Frank, I'll let you go ahead.
Thank you very much. Well, it's a pleasure to be here with this distinguished panel. Just a little bit about Atheer. I started working with Atheer a few months ago. Excuse me. And fascinated with the world that's being developed here with everyone. My work did start back in '89 in the mobile space, and I remember the world transitioning from wired phones to wireless phones. I don't know if most of you probably remember that, and having to design and work with that whole transition and getting people to understand what was happening. This is reminding me again of that. We're now saying that people can walk around and change rooms and change context and what they're doing and utilize a single device. I mean, if you remember the old wired phones, you'd have an office phone and you knew you were in an office and the buttons were specifically assigned for office work, or if you were home, it was a little more flexible, and they were always contextually based designs. And now, of course, we're putting glasses on people. Phones obviously transitioned into you never know where you were, and you had to use that device in situations which might be, let's say, even dangerous, like driving and things like that. So how do you actually design in such a way that it's safe for people, it's right for where they are and what they're doing? So it's a fascinating world that we're in now, creating for Atheer. I'm working now on all aspects of the brand holistically, the product, which is an enterprise-focused product. It's a Android-based platform, which is focused primarily on enterprise. And of course, we're making it in such a way that it can be customized for various different, whether it's medical or industrial, and create special applets and opportunities to customize, which means the design has to be very flexible for different environments, or the designs have to be flexible for different environments. Am I done with my 3 minutes? It's very tight. So anyway, the idea is lots going on there. It's a multi-gestural interface, so we have voice control, obviously motion, and a lovely gesture control, which is quite precise and wonderful, and different view modes, so you can look around or you can freeze it and operate it in a number of different ways. So there's lots of detail there, but what's fascinating is designing an interface, designing an experience that is so flexible, not only in how you use it, but where you'll be using it. So it's quite a challenge, and it's an exciting one, and it's great to be up here with all of these other wonderful folks.
Thank you, Frank. Up next, we have Sean White, who is the co-founder and CEO of Brightsky. And he's been working in the AR and VR space for over 20 years now. He's been CTO and a vice president at another company, and has also taught at Stanford University and Columbia University. Sean?
Thanks, Jason. I wanted to talk a little bit about some of the context of this. Some of you might recognize that. This is a cool system. It's sort of in particular, is an early VR system, not AR system, but it's one of the things that sort of led me there. You have little grippies that you can control things with your hand. You can move inside of a soundstage, a space. But 20 years ago, and this is from 1994, the systems were very different. Each eye was driven by a reality engine, which cost maybe about $1 million when all was said and done. We had folks like Brenda Laurel and Michael Neymark putting together a lot of the storytelling and a lot of the sort of amazing aspects of it. And the technology was cutting edge, but the design was one of the most important parts of it because it was about stories and about caves and about all of these different ways in which you experience a space you've never experienced before. Now, one of the things that led me to was finding better ways to kind of interact with stuff, right? Because we started off with these little grippies, right? Those little things were just force sensors. And in the groups that I worked with, we started doing things that were always in your hand, right? And we were asked to sort of take positions. At first, I wanted to tell you all that gestures are terrible. You should only do physical things. Or using eye gaze is terrible. You shouldn't do any of that. But the truth is, they're actually all great, right? And so the right thing when you're thinking about design is thinking about each of the different modalities and how they work together. These were a couple of explorations just to give you some context of things that you didn't have to necessarily look at, but you could still use to interact in AR and VR spaces. And one of the other things that was sort of important about this is that a lot of it came from history. So I'm curious, how many of you have done any sort of gesture work? Raise your hand if you've done any gesture work. Okay, small set of you. And how many of those people know like Queck's taxonomy of gestures? Right. So I think it's really important not to reinvent the wheel. So take a look at what's been done, right? Great. But then reinvent the wheel, break it, right? And so it looks like there's a great book on VR that you can use. There's a wonderful one by Doug Bowman called 3D User Interfaces that's worth looking at. And so, if you can, make sure you study your history. Make sure you actually hack things, because all of this was hacks that turned out into great interfaces. And then the last one, it's probably the most important, is listen to your users. So this is a more recent project. This is not being done by Brightsky Labs. This was just done for my daughter. And it's the internet perfect storm of kittens, Apple Watch, and augmented reality. But what was great about it is very simple. I mean, any of you could probably build this in an hour or so, and that's roughly how long it took. But when you put it into somebody's hands, right, you see what they start to do. And so of all those things that I've said, and hopefully what everybody else says, the most important thing actually is listening to the people who are using it. So in this case, I watched my daughter use this, and she started, there's a video you can see online, but she started petting the cat. And so then you can start to do some rubbing and things like that. And you discover so much, right? So I wouldn't overthink it. Just keep building as fast as you can. That's what we do at Brightsky Labs. With the 10 app is we build as fast as we can. Half of it is crap, but we actually learn from that. We learn from our users. So that's it. That's a position.
All right, thank you, Sean. Up next, we have John Murray, who is the founder and CEO of Seebright. And Seebright makes an optical see-through head-mounted display that's stereoscopic. And what's interesting here is I haven't really seen any others. Maybe they exist, but I haven't seen them. It uses a cell phone for a display. John is also the co-author of Flash, Building the Interactive Web. John?
Thank you. I'm actually CTO. So I have some stuff on these slides, but I'm mostly going to talk over them. I wanted to talk a little bit about 3 different paradigms when I think about interaction, but to put them into context, the title is Interaction is Last Resort. I'm going to cite Brett Victor and his Magic Ink piece in that the more we have to interact with the technology, the more we have to tell it what we want, and that's not exactly a desirable thing. Maybe it's more of a desirable thing for games, and so it's very important not to conflate gaming as interaction is desirable and software which does work for you that you would otherwise have to do yourself. And so that's sort of the paradigm that I come at it. So the 3 different paradigms are computing as ambient assistant, computing as intentional assistance, and computing as a machine to operate. An ambient assistant is where a computer recognizes you're trying to do something and it supports you in that goal. The intention-based is where you have something that you want to do, and the computer recognizes you're trying to communicate that desire to the computer, and then it tries to obey it. Some of the ambient voice recognition software is a good example of this with OK Google and whatnot. And of course, direct manipulation has worked historically really well for traditional PCs and laptops, but a lot of the interfaces could be simplified and designed more to assume certain things about your context so it can present a better interface. So I'm mostly just going to talk about how AR is different than VR. So in AR, the real world is more important than your pretty graphics you're putting in front of a person. In fact, if you have more graphics than you have the real world, you're probably leaning more towards VR than AR. And in that respect, your input device probably shouldn't be a two-handed game controller that locks your hands together like shackles. Instead, it might be something that's a little more expressive and something where you can have a free hand to interact the environment that you would otherwise want to manipulate, or perhaps to communicate to people in that environment. And something that we've learned from games is how continuous feedback is important. You have to tell the user that whatever you did was understood and responded to, and you can't let the user guess the state of the system, much as we have to do with everyone around us continuously. And finally, there are certain things about your human perception which are far more important in augmented reality than even in any smartphone, smartwatch, laptop application. And it's really a bad idea to conflate a Windows application that's designed for a laptop screen where the user is giving complete attention to something that should take advantage of your peripheral vision, what task you're doing, what your context is. There's just a lot of information that the app designer has that they need to work with dynamically that is not true in the case of a context-free application that sits in an operating system without any understanding of the user's current activity or state of mind or anything. So with that, I think I'm going to just skip my last slide and leave with the thought that augmented reality is most helpful when it's supporting users in their desires and in some sense making decisions. And we've already started looking at computers integrated into our decision-making process with GPSs. So for the 20% of the time that you're interacting with the system, you want it to understand you precisely and unambiguously, but most of the time you just want it to essentially support you in what you already want to try to do. Thank you.
Thank you, John. Up next, we have John Elvesjo, who is the founder and CTO of Tobii. And John sits on multiple company boards and has received many prestigious awards. And he gave a fascinating talk this morning on eye tracking, and he'll be continuing that discussion here. John?
Thank you. Yeah, so now it's all about eye tracking, that one modality. Actually, I spent my pretty much my whole life developing eye tracking, but I'm the first to admit that eye tracking is not the solution. You need all those other modalities. You need the whole thing. But I do want to say that eye tracking is fundamentally different as a modality to all the other ones, or at least most of the other ones, in the sense that if you think about it, if you press a button on a keyboard, if you do a gesture on your touchpad or on your touch screen, even if you do a gesture in the air, maybe you're holding something, you're doing a very, very active, deliberate action, and there, hopefully, the machine will understand that and act according to the established schedule of responses from the machine that is associated with the action. Eye tracking is fundamentally different. It provides a way for the computer to listen to you, listen to your eye movements all the time. Because as you consume information, your eyes move. As you perceive, a very, very large part of all the information that you take in is through your eyes. And we know exactly what you've taken in. So through eye tracking, it doesn't matter if it's eye tracking in a wearable solution or in a laptop or in a car, or if it's from Tobii or from somebody else for that matter, the eye tracker provides the machine with the possibility to understand you. It knows your emotional state. It knows if you've seen the warning or not. It knows if your eyes are looking at the screen, and just as an example, maybe the screen should be on when looked at and not on when not looked at, just to give you an example. So today, eye tracking is used by several thousand people. Just today alone, several thousand people here in the US use eye tracking from Tobii as their only way to communicate. They look at A to type A. They look at an apple to type apple, and that's their only way to communicate. So eye tracking actually works, and it's robust enough for people to rely on it as their only way to communicate. And therefore, it's also robust enough to use in AR, VR, and other applications as well. I would challenge everybody to think about what eye tracking could really be used for. Of course, you can look at an object and have that selected. Of course, when you talk to your machine, that speech could be better interpreted by knowing what you're looking at. If you look at the radio and you say something, or if you look at your wife next to you in your car and say something, that might mean different things. That's how we humans do it, so why shouldn't the machine? And there's a lot of data and information about you as a user that could happen, especially within gaming, for example. You could, of course, use the information of where you're looking to spend those limited resources, such as battery, such as GPU, CPU, memory, bandwidth, or whatever else, better if you know that the user is looking at the left-hand side of the screen right now, for example. Yeah, so just to kind of wrap that up, think about the possibilities that definitely go beyond just looking and selecting. And bear in mind that solutions for eye tracking in AR and VR, they are available. Tobii we're shipping our second generation wearable solution right now. And yeah, it's there. Thank you.
Okay, thank you, John. Up next, we have Tero Aaltonen, who is the co-founder and CEO of Augumenta. And he has an extensive background in engineering, but really he excels in everything. He's very multidisciplinary. He says that he speaks strategy, marketing, sales, legal, R&D, leadership, customer support, and perhaps most importantly, he speaks geek. And so, Tero, go ahead.
Thanks. I'll try to keep this non-geeky. So I'm from Augumenta. I'm CEO, one of the founders. And what we do is interaction software for mostly AR glasses today. I'm a geek, but I have even geekier friends. And one of my best friends is the guy on the slide. So that's Peter. So he started his academic research on like smart glasses and interaction, I think in 1999. And that was a time when there was no such thing as smart glass. So basically the first thing he did was get some pieces of hardware from here and there, put them together, and then that turned into a glass prototype. And once he had that up and running, he started thinking about the interaction and what would be a natural way to control a device like that. And you know that every time there has been a new kind of device category, say a tablet or a smartphone, I mean, they always needed a new way of interaction. I mean, no hard feelings, Frank, but you didn't really get the first Nokia smartphones, right? If you look at, I was living back in Finland then, and I was very close to Nokia myself, and I mean, Nokia was building all kinds of cool devices and putting in more and more functions, but the thing was that they were becoming very, very difficult to use. And I think then when Apple came with iPhone and just basically brought multi-touch touchscreens to mobile phones, then that's the moment when the market really opened. So the devices had been there for a while, just too difficult to use and really reached that huge success on markets until there was a proper way to interact. And I think that's kind of what we are trying to do with AR glasses. So glass today is very much a tool for different enterprises. It's something that Google tried to bring to the consumer side. We all know what happened there. So we are much like the rest of the industry today. We are very much focused on the enterprise use cases, and there are a couple of things that are very important there. For an enterprise customer, things just have to work all the time. And what they want to do with the glass is not only view information, they also want to input. So that's really the kind of key of what we are trying to do as a software company. So to provide these kind of virtual keyboards, using gesture control based on the camera in the device, creating these augmented overlays over your hand, and then populating that area with a keyboard, different kind of button combinations or sliders, basically whatever you might need to input or manipulate existing information. So So we are pretty much a software induction company. We try to make this thing work on any AR glass. We are getting some questions from the VR side as well, but I would say today the main focus is still on AR. So these are some of the segments in the industries where we are enjoying quite a bit of traction.
Okay, thank you, Tero.
That's it.
Now, the first question I'd like to ask of the panelists, if you could go on to the next slide, is I looked at VR interactions and I kind of categorized them into different types of interaction categories. And so I went back and I compared those, okay, how do we interact in AR? And at first I thought they'd be very different. Maybe there's only a few up there that would be similar that, are kind of could cross over to AR. But the more I started thinking about it, the more I realized that a lot of these actually do cross over. Maybe not exactly and specifically, but the kind of high-level concepts work in AR as well as VR. At least that's what I saw. So my question is for you guys, do you see much overlap in AR and VR of different ways of interfacing with the computer? Or perhaps you don't. Maybe you think they're completely different. Anyone?
Yeah, so we mentioned this earlier. There are 3D user interfaces, right? And most of the things you see in 3D user interfaces, like I'm sure in your book and Doug Bowman's book, right? They are similar. You will see them in VR and AR. You still have to, point. You still have to grasp. You still have. I think you had it in there, but system control and things like that. My sense is the place where there is significant difference is that. In AR, there's a background you have to deal with that just doesn't exist in VR. In VR, you control everything. In AR, you don't. And so now you can use the physical world as an interface. You can use the physical world and have a locus of interaction that's around the physical world, not just in all of the virtual things that you have. Right?
I think that it's important to consider what's going on. I mean, it just really just depends. A lot of what we're trained to do every day normally, I mean, you brought up the mobile phone. The traditional mobile phone was very easy. It didn't have a lot of demand. And so for a decade, that was okay. But when there was the opportunity to make a real quantum leap in flexibility on a display, yeah, it required an entirely different interface. But people were stuck on buttons. And the funny thing is that all the research said, we love buttons, we don't want virtual. So one of the sticky points that I think is really important is we don't look too much at focus groups in developing these things, because one of the hiccups I think that landed up Nokia where it isn't, or is, today, was the fact that when we would put touch concepts in front of people, which were replacing buttons, which is a way to do things, they said, no, I don't want it. Literally millions of dollars spent researching and asking people what they preferred. So there's a very complex part of this is VR. Like you say, they're gaming systems. People are used to operating in their game, and that's what's most important. It's not necessarily, and then there are other things you can point and do things, but it has to work with the game. But with augmented reality, you're interacting with the world. But then the question is what they do in the real world compared to what they're doing virtually in the real world, and making sure that there's a synchronization in that. So if somebody's used to pressing a button at a fuel cracking plant to make sure that something doesn't explode, right, that it's the same action if he goes over to the hard console, and that you don't give him another thing to remember, because it's really important that he presses that button or the plant blows up. So it's that kind of crossover. So what's important is how does it relate to how people are trained? People don't like the idea of having to change their way of thinking just because it's a different sort of interface.
I'll take a turn. So I definitely think in augmented reality, like you said, that you have the real world to deal with, and the real world is often more important than putting an interface that might obscure some piece of information in the real world. You also have to sort of work with what you're given, so it's possible that some physical object has some affordances that could be used as an interface if it knows what you're doing, and we really do like tactile feedback. It's why people preferred physical buttons for typing initially, but they liked a bigger screen more. And that was the hard part about deciding the feature vectors. Now, Seebright decided to go with physical buttons on our controller, partially because it's a lot easier to use muscle memory to access a set of verbs discreetly and unambiguously, especially when the controller shouldn't be in your field of view. And so that's partly why the remote control hypothesis is, man, you're looking at the TV, you don't want to search around for the next button, you just want to keep hitting it over and over again. So in some ways, VR is more of an aesthetic experience of the interface, whereas AR is more like a subtle presence of an interface when necessary, but mostly the world is the interface.
The world is the interface. That's good. I can just kind of relate a little bit from a eye tracking perspective, where it actually is fairly different. The explicit interaction, the pointing that you could potentially do is fairly similar in AR and VR. Given it's very dependent on the use case and what kind of what you're trying to navigate, of course. But the concepts are similar. However, on the implicit side of things, which is something that is quite important within eye tracking, it's quite different. VR is still today very limited by its resources. Ideally, you definitely want to have 2x 4K in your resolution, and you want to have that rendered really good anti-aliasing and everything, and that's bandwidth and CPU, GPU is pretty intense. So eye tracking plays a large part in that, trying optimizing, making sure that you spend those resources where they are needed. Right? If you can't perceive the better quality, why render the better quality, basically? And the same thing would go for special niches or special kind of use cases in AR, where you might have more of notifications, for example. If you're wearing a display, it's see-through, it's augmenting your reality. It might pop up information. It would benefit from knowing if you've seen that, because then it could take it away, or if you haven't seen it, it could emphasize what you just haven't seen. So in terms of interaction and some of the kind of eye tracking specs, is fairly different. And they as you know, they tend to look very different physically, different size, different power budgets and so forth, and AR and VR. So it is fairly different in terms of doing eye tracking applications.
Okay.
So just going back to that previous comment that we like to touch things. That's very true. There was a study saying that if you create virtual interfaces and if you just put buttons up in the air and then you would click like this, it's actually quite demanding for the user. You have to focus quite a lot, kind of make sure that your finger is meeting the button, if that's the kind of interface that you have. And that's kind of the reason why we decided to put the buttons over your hand. So we have the palm area, which means that the button actually is in the same location every single time you're using it. And kind of you learn to remember where it is, and it's a bit less demanding for the users to use these kind of interfaces.
Interesting. A few years ago we had a panel on motion gaming when it was, PlayStation Move versus Microsoft Kinect, and the conclusion is we had a Richard Marks from Sony as well as some Microsoft people on the panel, and the conclusion really was similar to what you guys are saying. It depends what you're trying to do. There's no universal answer. Like any great question, the answer is it depends, and I think that's what we're saying here. The next question I'm especially interested. Someone asked this morning about the Midas touch problem with eye tracking, about how everything you touch is suddenly selected, and that was actually a question I was thinking as well before even that was answered. And I was curious: is that just as simple? It wasn't really said how. It said, yeah, that can be solved. We figured that out, but not really the details. So I'd love John to hear the details. Is it as simple as just going back to buttons, maybe looking at something and pushing a button, or is there more to it than that?
Well, I think actually the world has a long way still to go in terms of understanding what eye tracking is really meant to do, what it can do. I think it's a phenomenal interface, but it's also terrible at doing some things. The earlier session, I pointed out the fact that you cannot draw a circle. Trying to do handicraft artwork with your eyes, even though some people do it, it is extremely tedious. It's really hard. The eyes are not meant to do that. The eyes are great at other things. For example, when you search for information, if there are plenty of information there, several objects, and you're looking for something, by definition, your eyes will be on it at the same time as your brain can register that you found your object. So if let's say you're searching for a folder, You're switching applications. You're looking for that open Word document that you want to switch to, and you do it all the time. Maybe you're browsing the web. You're looking for a link, or by definition, your eyes will be on that piece of information as you understand that you found what you look for. So also by definition, by the minimal effort would be to release a button or release a command, and thereby clicking through on that thing you found. So another Midas touch problem. So everybody we talk to still today, they think about looking at objects and blinking, or looking at objects and saying something and thereby selecting. And they would tell me, John, this is great, then I can throw away the mouse. Or, I don't have to pay for the touchscreen thing in my laptop anymore, and whatever. It's not as simple as that. First of all, you don't want to just auto-click on everything. Like, you don't even want to highlight. You don't want to move the mouse cursor, and that's the worst idea. Several years ago, we shipped an eye tracker to a company known for their great user interfaces, and they came back and told me, John, you know what, eye tracker is never going to make it into computers, because putting the mouse cursor where you look all the time is actually a terrible idea. Because the eyes are vibrating, and so did the mouse cursor, and it was actually exactly where you were looking all the time, so it couldn't be more annoying. Eye tracking needs to be complemented, preferably with a physical switch. That's the best, if you do insist on point and clicking. But there are other things. Let's say you have a screen in front of you, and you look to the left-hand side. If that screen would then actually viewport-wise tilt towards that direction, as it does in Assassin's Creed now, for example. If you look at the left-hand side, it actually turns the viewport of that first-person shooter view so that the head turns. They call it the infinite screen, and that's what it is. It's an infinite screen. It's great. There's no confirmation. There's no clicking. There's nothing. If you look at the center of the screen, or if something just comes up and comes into the screen, and you keep looking at it, as it centers, the movement will stop. And that's very natural. The same thing goes for two-dimensional scrolling. So with the right interfaces, there is no Midas touch problem. And auto-clicking is a terrible idea. Highlighting, moving a mouse cursor to where you're looking, terrible idea. If you want to do that, then use any of those many keys that you have on the keyboard, for example, in that scenario. Use that tactile thing. Or there are other reasons to have buttons or switches, or tapping on your hand, whatever, a gesture, even a word to confirm, rather than having a Midas touch auto-touching thing. Sorry, long answer.
Does anyone else have comments on that?
Actually, I have one. So the tricky part is your eyes are only partially under your conscious control. You actually can't choose where you're next looking because you don't know what's there until you look there. You have some level of automatic. And that's, again, the measuring and determination of intention of the user and discriminating that from the autonomous sort of interactions that we make. And that's very much like a data problem, and we could solve it with machine learning algorithms, but more to sort of support the intention of the user as opposed to interpreting it as a direct command. And that, I think, can bleed into any number of Internet of Things or sensors, which are ambient sensors of our current intention, but they have to crunch some numbers in order to determine it, and then figure out how best to interpret it. So.
Next question. Okay, and does someone have the, I'm sorry, I lost my clock up here. Can someone tell me how much time we have?
It's 2:45.
Oh, okay. Well, why don't we, I'll ask one more question, but as we do that, why don't you guys start lining up? The gentleman in the front row has a microphone. If you have questions, then we'll have some time to take questions from the audience. There you go. Well, why don't you go ahead if you're ready, then we'll just pass on my question.
Tim Merrill from DigiCapital. When you try the various products that are out there, the positional tracking seems to be incredibly important in terms of whether it tricks the brain or not. Well, how do you think about positional tracking in terms of the way it affects the other interactions?
Are you talking about head tracking or
Yeah, can you?
eye tracking or?
You get up, you walk around,
Yes.
things stay where they should be.
Yes. I mean, so tracking's a massive subject, right? There's tracking where your head is, tracking where your gaze is going. There is registering objects in the right place. For the most part, anything that is registered to the world, and if you look at a bunch of the work, right, there's sort of display registered or display fixed. There's body fixed, and there's world fixed, right? And all of those actually require, the display fix is the easiest one, right? That's what Google Glass effectively does, and it's an information display. The other ones are harder, and in particular world fixed, because you need to know where the person's gaze is and you have to actually know where the world is, right? I mean, in terms of how important it is, it just depends. Again, I hate to say it, but it depends. There's a lot of really good work from Georgia Tech and Blair McIntyre's group where they would sort of do estimates about how much error there was for different tasks. And for some things, it's okay for the light to be fuzzy over there because you're just trying to roughly know that in that direction there is a piece of information you care about. And for like Nassim Navib's work on tumors in breast cancer, it has to be millimeter precise in terms of tracking. So for the most part, it just really depends. I mean, what's kind of heartening is that, it's my view, tracking has made some significant advances in the last few years. Not just the sort of high-end Vicon-based tracking where you're using instrumentation and things like that, but a lot of feature-based tracking. I don't know if anybody else has anything to say.
All right, I just want to say there's some really good lessons to learn from vector-based software in CAD, where oftentimes giving people 3D mice and giving people a lot of dimensions of control can be really bad for the end result. Like, you have this idea in your head of a certain number you want to get to. You don't want to get your hand to be right on that number. In fact, I think the most instructive example is Google SketchUp, where they have snap points that are more intuitive and easy to articulate your intention of your space traversal to the computer rather than having to actually mimic in one-to-one interaction with the space. And I think that's going to be true with AR, that it should recognize sort of spatial snapping points and really sort of understand and not require precision of movement, especially with muscle groups that may not be as well trained as a surgeon, for instance.
Because you hit on something really well there, just really quickly, is what?
I was just going to say go to the next slide so we can see the names of the speakers.
Oh, sorry.
Go ahead.
You hit on something very important. Being an industrial designer and having retrained myself in the world of design about a decade ago when CAD became like the only way to work, I noticed that every different computer-aided designer had a different way of working with the reality, the world or the object, how they would like to manipulate it. So it is an excellent lesson, and I think that it's just interesting for myself, living in that world. I have my way of doing it, and if I go onto a screen with the same software with somebody else's settings, it's miserable. So I don't know how many of you are out there that have this experience. So this fine-tuning to the way you feel the world, and it's radically different between different users. So it's really important to have the flexibility to do it right. There may be a moment where absolutely the only way to enter text quickly and efficiently is to look at your hand and do it as you did it. There are other situations where you want more flexibility for various reasons. Eye tracking, all of these, they all have their place. And I think about the human, you interact with gestures to communicate something as simple as I'm happy or stay away. You have voice, you have tonality. All the technology that we've developed over our arguable number of years that we've been developing on the planet, we have all of these communication technologies that we take for granted. And so we're competing with that. So I think it's on both ends. It's not only how we see, how we communicate. And when all of that comes together and we understand how we work as human beings and can intuitively represent that with options that are as fine-tuned to the individual. What we like about different individuals is they all have a different character in how they express themselves, like I'm doing right now. And that is, I think, the options are as variable as that. So if you can invert what I just said a little bit into creating an experience, I think that the fine-tuning knobs have to be extremely easy for people to tune them, but at the same time, they want all of those options, ultimately. Sorry, that was a long one.
There's a question here, Vince, in the fifth row there.
Hello. Very interesting panel. My simple question is, how is the current interaction will impact the future of education?
So could you clarify that a little bit, maybe?
Now, I just want to see, with the techniques and solutions students available, what's the future of education would look like from 5 years from now? And what are you thinking to impact those education, either at school level or college level, and really make an impact on humanity?
Well, I can start on that.
So I'll dig on.
Oh, go ahead.
Well, so there is one thing. There are a number of interesting studies about situated learning, which was a particular style of learning, and then in multimedia. And this is back in the CD-ROM days when people were starting to put multimedia together. And when we see information in context, when we learn in context, we actually remember it better, right? And so you can go back to all these studies about that. And so the promise of AR is actually situated learning, right? That you have information in context, you have interaction in context. The world is the interface, right? And so if I think about where education would be, I mean, for VR, it's great for simulation. For AR, like, it will be fantastic for not just learning about the world, but actually getting better at the memory and the recall about the world. Jason?
There was a report that came out a few years ago. I don't remember the name of that report at the moment, but it was interesting. It came from the top of various organizations looking at AR and VR in education. And I was surprised because historically education is kind of slow to move forward, but they really saw first, the mobile market in education, but also they called out AR and VR technologies, which I was, surprised with. That was like 2011, before the Oculus Rift, they called that out, right? So I think there's interest there, and there's huge potential. I mean, that market is so big. There's a lot of barriers to entry, and it's as simple as maybe tagging items in the environment. So you look at something, or you point at something, and there's some audio or some visual tag that brings up information about that. Something as simple as that, I think, could add huge benefit to create better understanding of the world.
So education is actually a pretty close topic to my heart. I actually think it's one of the few use cases that AR will truly barnstorm the mainstream with, partially because AR has this potential to understand what we're doing and how to help us do it better than any teacher whose attention can never be dedicated to what we're looking at, what we're particularly understanding, trying to match our mental models with whatever subject domain we're trying to understand. Whereas in AR, not only do you have the benefit of working in a situated environment, possibly with other people, whose channels of social communication is as important as the subject matter, since a lot of the jobs still depend very heavily upon being able to communicate with people. I think that AR will be superior to VR in many of these contexts where we have to do work with other people, and we need to learn how to better communicate with them, better understand how to change our mental models and correct inaccuracies in them as you perform whatever work it is. And with AR, you have access to a wealth of contextual and personal information about how somebody is actually interacting with the environment, and able to give them demonstrations from a first-person perspective of how to do it correctly in the case of, say, manual skills. So I think AR and education are a great match, and as long as it's affordable and it's accessible, it'll have a great benefit, especially since our school systems are fairly overburdened with 30 to 100-person classes, and the inability of a teacher to manage that many people's mental models at the same time.
I know we've done some focus studies lately, and the kids, they literally, we haven't seen any fist fights yet, but boy, if you have like two groups, you're doing a between study design, if you don't show that to that second group, you have to. We've been advised you have to show it to both groups because they'll be upset. I mean, kids literally, we've seen them cry when you take away the controllers. It's there's some challenges there. There's also tomorrow at, I believe it's 3 p.m. There's an immersive VR and AR education panel as well. So anyone interested in education, be sure to check out that panel. I saw another question back here.
Yeah, here. I want to just put a hypothetical question to everyone, is that imagine you're in the position of someone like Tim Cook, where you've got the realm of reality, not science fiction, but you've got infinite resources and a near-term time frame to ship magic AR glasses. What interface would you build? What would you build into it to give that ultimate interface?
Come on, France, to take that one. Yeah, seriously.
The Atheer interface, of course. I don't know how you answer such a huge question like that, but it's he has to understand who he's selling to, first of all, and what he wants to do with it. I think that the reality is it's not ready for prime time, in my view. I mean, the consumer. Everything that we're talking about is very much more focused on very targeted areas, whether it be education, industry, institutional. There are lots of really wonderful targets. So I think he would look at it that way, first of all, and then in that situation, what's best for that in terms of. I mean, I'm excited that Atheer is actually using an Android-based system, so we can look at all of the Android apps. I mean, right now you can go in there and you can work with them and play around with this. Some really cool things going on with that, which is a nice step to say that, well, instantly you can use that and amplify from there without having to reinvent, because there are a lot of people familiar with Android. And so we can being able to move very quickly with that and use the tools, the multimodal aspect of it. You know, you need a very flexible tool in porting, whether it's eye tracking and voice recognition, using it all together. So hopefully you wouldn't have to make a decision that only eye tracking or only this or only that. That's just not going to fly. It might, in a surgical theater, for instance, what you want is the ability to look at information, replace maybe all of those screens that are hard for him to see because of all the tubes and the whatever, so he could look around and overlay several different, whether it's an X-ray or a 3D model of a heart that he can turn around, all the things that you see out there. That's really important, and maybe if both hands are busy, he really needs to be able to switch to eye tracking mode, so he can go straight to that for a moment, but then he may want a more precise way to look at things, so then the gestural interface from Atheer, for instance, with voice. All of these things stack together, and I think that he'd have a really hard time picking one.
First, I'd acquire Matayo. No.
Actually, Apple, I give them credit that they actually are closer to the solution than you might think. For one thing, Apple understands that consumer and enterprise are vastly different worlds. They have different concerns, different problems, different motivations, different purchasing decisions. If you want to solve it for the consumer world, solve everyday problems. And don't mess with people's privacy. I think those are the two things that you should do if you want to win the consumer market. Solve something that they have an itch every single day, and do it in a way that doesn't make them fear that you are taking all their private information and selling it.
Okay, one last comment, then we'll need to shut down here.
Yeah, I mean, Apple, that's consumer, right? So I would skip all the niches and go for an application where it could be mass adopted pretty soon. So gaming. So I'll go, and they're big on, you know, tablets and phones. So I would do something that is very close to the Samsung Gear VR and create a good API for that, and a good API including also not only the 3D parts of everything, but actually the positioning. We had a question about that earlier. It is tremendously important, and it's hard to do within a cell phone, but it could be done well, and I think they will.
John, so one last thing about this is, I think Apple actually is positioned in an interesting way because they are creating an ecosystem of devices, and the problem is that, I mean, even for people who make watches that aren't made by some of the handset manufacturers, it's tough because it turns out that if you control the handset, you control the interactions that eventually feed the watches. And so I think they're in an interesting position. I would actually probably do what Microsoft is doing because gamers are used to trying out weird devices, new things like that. Right? It's a great first try. It actually almost feels like a rebirth for Microsoft more than Apple right now.
I agree.
Okay, well, let's go ahead and thank our panelists.